Alright everybody, so we're going to have to do things a little bit differently today. We still have a good segment of our class testing, but I don't want the rest of you having to sit around for an hour just doing nothing. So we're going to work on the lesson today, and then once everyone's done with testing we can get into groups and work like we usually do. But for now, work on these notes quietly by yourself. Let's give all the testing people some quiet so that they can finish up their testing. And in the meantime, what you have is your notebooks out, and you're working on 8.12. More on collinearity. Now this is a subject I know we've covered before, but we're looking at it through the lens of geometry and not algebra this time. Now, other thing is, as you go through this video, it's going to go kind of quick. If you're copying things down and it goes too fast, just pause the video, and then when you're all caught back up, restart. Alright, so your goal today is to understand how the distance formula can be used to prove collinearity. Now, in the past, what we've done is this. We've looked at collinearity if we imagine 3 points, A, B, and C, and we looked at the slope. If the slope between A and B, which in this example is 4/10, which reduces to 2/5, is the same as B and C, and of course the line segment A, B, and BC share B, they're actually joined together, then it must mean that all 3 points are collinear because they're all along the same line with the same slope. That's how we used to prove collinearity algebraically. But we're looking at geometry right now. So we're going to look at something completely different. Alright, so this is the triangle inequality. And what it says is that if you've got a triangle, the sum of the lengths of, accidentally hit the key, the sum of the lengths of any two sides of a triangle must be greater than the third side. And if you think about it, it does make sense that if we piece any random triangle together, that in order for there to be space inside the triangle, that they all kind of join at the corners, but it creates a triangle and an open part in the middle, then that the three sides, two of them added together, must be greater than the third. So, for example, AC, which is 5, CB, which is 3, 5 plus 3 is 8, 8 is greater than 7. But it doesn't matter which two sides I pick. I can do CB and AC, which are 3 and 7, which add up to 10, which is greater than 5. And then the last pair, AB and AC, 5 and 7, which is 12, is greater than 3. Okay, because if this wasn't the case, this is what would happen. So imagine this real rough animation here. Let's say I've got triangle ABC and it makes a triangle. And I draw this imaginary line going through B, headed towards line segment AC. If I take B, and imagine I could pick it up on this slideshow and slide it over. So if I pick it up, slide it closer to AC, I'd get this. If I slide it over even further, it gets closer. And if I slide it all the way, all of a sudden I've got B where I've slid it and actually closed the triangle so that B is now on top of AC. Now if you think what's happened with the measurements, here the triangle inequality holds together. I take any two sides, they'll total out to be more than that third side. And still the same thing here and here. But when I get to here, line segment AB, or the measurement of AB, and the measurement of BC added together now equals AC. So the triangle inequality no longer holds because, well, we no longer have a triangle. What we have is a triangle that's been smashed down into a straight line. Well, if you think about how that worked out, what we get is this. That when AB and BC, those measurements, add up and equal AC, not greater than, but equal, then that must mean that we're dealing with a triangle that's been smashed down to a straight line. In other words, when this measurement and this measurement added together equal the long measurement, then they must be along a straight line. So if AB plus BC equals AC, then A, B, and C must be along a straight line. So this is a way to prove collinearity with the distance formula rather than the slope. And so that's going to be your work today. So here's what I'd like you to do as the finishing part of your notes. I'd like you to decide whether the following 3 points are collinear. And you're going to do that by finding the distances between each pair. Alright, so imagine this is triangle XYZ and we're trying to see, is it a triangle? Do the sum of two sides end up being greater than the third side, or do they end up being equal, which means they're on a straight line? Okay, so pause the video, try this out in your notes, and then when you're all done, move to the next slide. Alright, so let's take a look at the answer. So, if I do my work for the measurement of xy, I do the distance formula, subtract the x coordinates, square them, subtract the y coordinates, square them, add them together, and square root. I get approximately 4.47. Had to round it off because it's an irrational number. If I do the measurement of yz, I get 6.71, and if I do the measurement of xz, I get 2.24. So now if I take a look, let's take the two smaller measurements, which are these two, add them together. It turns out they do equal the third side. So 2.24 plus 4.47 equals 6.71. So I don't have a triangle here. What I have is basically a triangle that's been smashed down into a straight line. So x, y, and z are along a straight line, and they are collinear. Alright, so this is the work you're going to try out today. You can either use the online textbook since your iPad is unlocked, or go grab a textbook, but again, do it quietly so our testing people can finish. I'll let you know when everyone's done testing. The assignment's going to be up on the board, so just copy it from there. And we're working independently today. As people finish the test, we get it so we don't need to be quiet anymore. We can then go ahead and get into groups. But I'll let you know if and when that happens. In the meantime, work independently, work quietly. Let's let our fellow students finish up their testing. And yeah, good luck with the assignment.